Hey everyone, I hope you all enjoyed day one, and I'm sure you're going to enjoy day two as well. But for me, day one was super crazy. It was making me nuts, making me go nuts. I was seeing like Mohit and Dana do their hosting act, changing dresses, props, their increased energy levels. It was like too much for me to handle. So I went to Manish, our general manager, right? I said, like, you need to pull me out. This is super crazy. I am not going to do this. Then Manish, in his own convincing voice, he was saying, like, you are going to do well, right? You're the chosen one. The moment he said chosen one, I was thinking like the Neo character in the Matrix movie. In fact, I got levitated a little bit. And then I asked Manish, are you sure? Like, you never believed in me so much. Then Manish said, like, to be honest, like the others are working. Anyway, welcome to day two of the DevOps track, right? My name is Divakar Kusuma, right? I'm a senior customer success architect. Basically, what I do is like I make sure that the customers are getting the maximum value from the investments they're making. That's my job. It's super cool and super easy in a way, considering that it is GitHub. Obviously, they're going to see value in it, right? So it's less work for me. Don't tell my boss, but that's what the fact is. Anyway, with me, I have Richa. Hopefully, she has much crazier work schedule and work than me, tougher work than me, right? So I'll let her introduce herself. Richa?
Thanks, Divakar. First of all, a very good morning to everyone joining us today for GitHub Constellation Day 2. I'm Richa Kumar, Senior Director Software Engineering at GitHub, and I focus on making GitHub the home for all student developers. I'm based out of Hyderabad, and it's a pleasure to be here with Divakar. We are going to be hosting the DevOps track. So, as Divakar mentioned, we've had an action-packed day one yesterday, and we had some great keynotes this morning. Divakar, what's been happening? What has stood out for you so far?
Oh, like I'm still stuck with day one, right? Um, for me to begin with, Nandan was amazing, right? He was
Absolutely.
telling the growth story. I don't know like how we could summarize it in 30 minutes, but all those
Mhm.
facts and figures, that's overwhelming for me. And it actually took me for a ride. Like, every day in your life, you're using that UPI, Aadhaar, and soon it's going to be like that digital commerce network. All of that we are going to witness, and we have witnessed in our generation. It's not like a couple of decades ago or something. Like all this happened now, right? It's amazing that these initiatives came from the government and at a speed that you could not have imagined in the past, right? And even some of the even moments that we discussed with the Ministry of Education, like I remember Dr. Buddha's statement on how he's hinting on what to learn, the A B C D E F G, right? The analytics,
That was
Bitcoin,
amazing.
etc. And you were saying like G for GitHub. Wow, I was thinking, wow, that's super. That's free advertisement for us, right? That's super cool for me. What about you, Richa?
Yeah, I actually got a chance to catch some of the keynotes from this morning, and it's so exciting to hear about the thriving developer community in India, right? And Stormy shared some numbers. We heard from Thomas yesterday. 8 million developers on GitHub in India, and trending towards 10 million in 2023. And impact, 10 million projects worldwide, if I'm getting that right, that depend on packages that are developed in India. This is amazing, you all. Keep that momentum going because you are helping make India a leader on the path of digital innovation. In one of the keynotes, Stormy also talked about enterprises. Enterprises too are now, taking dependencies on open source software and contributing to it. And as a hubber, I'm so proud that GitHub plays an important role in facilitating this. Collaboration and community has always been at the heart of GitHub's mission. And so, how is GitHub helping developers? Matthew, in his keynote, talked about some cool new features that are coming our way that will enable the collaborative style of working, help developers be more productive, and write secure software. There was discussions, Copilot, CodeQL, and Code Spaces. And we're going to be hearing about all of these over today across all the three tracks. So stay tuned. So what's lined up first, Devakar?
Wow, looks like Richard, you're all caught up. Thanks for summarizing that for us. First session, we are going to have a session from Prashant Subramaniam. He's joining us from Google Cloud. He's a developer advocate. And he's going to teach us a thing or two about how we can use CI/CD along with Google Cloud, right? So it's going to be interesting. So stay tuned. Prashant, over to you.
Hi, welcome to this talk. I am going to be talking to you about how we can implement CI/CD pipelines and how you can do that using GitHub Actions and Google Cloud. My name is Prashant. I am a developer advocate with Google Cloud, and I lead developer advocacy for Google Cloud in India. Let's start with a simple thought. We see software all around us. What is common between the software that's running all over the world, in production, in various devices? Any thoughts? All of this is written by a developer. Now, of course, I am oversimplifying this. You have no-code tools which can produce software. You have generated code these days. However, all of that it also was written by a developer. So developers are the ones that is actually building a lot of software, and it's important to take care of developers' needs in order to be more efficient and write more and more better software. Now let's look at this whole developer experience from an outside point of view. This is how the world sees it. You have a developer, the developer writes some code, the code ends up on a production server, and you have an end user that is interacting with the application either on a server or on a device. This is a simplistic view, but let's deep dive into what the developer themselves are going through. Not all code that makes a software is written by one developer. There are other dependencies in the source code which need to be put together, and this is what makes the complete source code and the final product or the final software. In larger applications, it is not just this one developer that's doing this, but there are also other developers, multiple developers who are working on the same source code and using all of these dependencies to build the final software package. Now, not every developer or the contributor is necessarily on the same version of the source code as well, right? Each of them is in a different stage of the development process. They are working on their own features. And in order to be working on the latest version of the repository, it needs some sort of a hygiene. It needs continuous integration back into the fork or back into your branch. We recommend frequently pushing smaller changes of the source code so that it's easier to merge conflicts and easier to help resolve the code and integrate the code together. Now, if this is not done, then what would happen is if this hygiene is not followed, then the feature branch will become quickly out of sync with the main source code, and it'll become a nightmare to maintain. Now, then again, you have developers who are working in environments that they are comfortable with. There are developers working on Windows, on Linux, on Mac, using different tool chains, using different IDEs. And a lot of the times, the runtimes and the software package versions that each one of them is using, it's different when you go from one environment to another. When the maintainer has to now integrate all of this, they are left scratching their heads. Has the right hygiene been followed by each of these developers? Have all the tests been run? Are the right versions of the dependencies used? These are questions that come in the mind of the maintainer. Now, of course, this can be checked, right? At the pull request, when the pull request comes in, the maintainer can check all of this, but it needs a lot of effort. And this manual effort that is needed and the ambiguity around this whole process, what makes it a very poor experience for both the developers and the contributors, as well as the maintainer of the repository. And when you have software that looks like this, that is when it becomes you have a lot of other concerns, right? And this is how actual software is. A software is not just one component, but you have multiple components that are built and talking to each other. So what you need to think about is the piece that a single developer touched, is it working well together with all the other pieces? While we have built integration tests, have the tests been run? Have the tests been run correctly? Has the integration environment been set up correctly by the developers before they push the code? How difficult is it to set up this environment? It is an environment where you have all different pieces of the software that have to run together. For every change that the developer makes, how much time does it take to bring up such an environment where all the software has to be firstly compiled, built, and then deployed into an environment like this? And then who is going to maintain and troubleshoot such an environment? Who is going to monitor that all the code is compiling fine, that everything is running fine, and that the final output is consistent with a software that we can then take to production? This is a lot of effort, right? And a lot of thought needs to go into this. And this is why there are some industry standard best practices that we recommend that would help developers. Firstly, using a good source code management system. You want to use source code management system that allows many developers to work on the same piece of code, on the same source code. You want them to be able to collaborate. You want them to be able to manage different versions of code in an easy way. Using containers. Use containers to package all your compile time and runtime dependencies into one single unit of deployment. This way, anyone running your code or anyone working on this application will have the same experience and functionality that when they deploy this piece of code. I can't stress the importance of this one enough, but unit tests is extremely important. The only way in which developers can work in a collaborative environment is when you have near 100% unit test coverage for all your code, for all your modules, as well as a comprehensive set of end-to-end tests that take care of all the integration between different pieces of software. Finally, with all of this in place, you still want to ensure that you have a good automation pipeline, that you have a CI/CD pipeline. This will help take away all the mundane work that a developer has to do. Thus, one, taking away all the manual effort that is needed by the developer when they do the integration, when they do the testing. And secondly, what if the developer forgets to do this at a point of time, right? So doing automation takes away all this effort and all the thinking from the developer as well. So with that, let us now go into a demo. What I will be doing is I will show you how we can use GitHub, GitHub Actions, and Google Code and Google Cloud to put together a working development pipeline. We will now cut to the demo screen. All right, so here I have a repository. This is a repository that I have on GitHub, and I have set a GitHub action. I have defined some GitHub actions and workflows in this repository. Sorry, I will need to cut back to the slide. Okay, let me define the demo scenario first. We have all our source code, which is there on GitHub. In this scenario, we have multiple developers who's working on GitHub on the source code repository. We will have one of the developers who's opening a pull request with some changes into this code repository. Now then, using GitHub Actions, what we will be doing is we will be pushing this source code into Google Cloud Build. Now, Cloud Build is Google's serverless CI/CD platform that allows you to build, test, and deploy your code. Once the code is built, the code is then pushed to Artifact Registry within Google Cloud. Artifact Registry is a single place to store, manage, and secure all of your built artifacts, including your container images. Once this process is successfully completed, once we have the final compiled image, we will again use GitHub Actions to write a comment back into the pull request to indicate that this process worked fine. So this is a scenario that I'll be setting out to demonstrate, and I will now switch over to my GitHub repository to show how we have implemented this. I will cut to the GitHub source code. Great. So this is the source code that I have. I have deployed this on GitHub. It's a sample REST API application which exposes an endpoint. I also have unit tests written so that we can check if the code compiles, if the unit tests run or not. I will demonstrate the application first. Here I am on Google Cloud, and this is the application that I have. So the application, I have just run the tests. The tests are running fine. And when I start the application, I will run this in port 5000. And here we will see that the endpoint should be hit. Sorry. All right. Yep. So here we will see, I will be opening the application that I just started, and you see that the endpoint is hit and a response is got back. This is the application that we're going to be working with. So for the purpose of this demo, what I will do is I will go into the source code and I will make a change to the file. Let us go into the feature branch. What we're doing again is we are simulating a pull request. So the first thing is I will go into the server. I will make a change here. Sorry about that. Yeah. All right. So I am making a change in the index.js file. This is responding some JSON, which is what we saw in when I ran the application. And let's say hello GitHub. This is going to be my change. It is always a good practice to write some indication of what you're committing, but in this case, I'm going to skip that and very quickly make these changes so that I can show the demo. This is also going to make the test case fail, so I will also adapt the test case accordingly to check for what I sent back from the code change. All right, so this is a change that is made in the feature branch. What I will do now is I will go into the pull request and let us create a new pull request. We will select we are now comparing the feature branch to the main branch, the two changes that I made on the index.js and the index test.js, and we will now create a pull request. Again, give some meaningful comment and let us create the pull request. As soon as the pull request is created, you will see right here that the GitHub action that I have defined has triggered. Let us go into the Actions tab on GitHub. And here you see that a new workflow is running. What we will be doing here is we will be checking the code out. We will be pushing this to Google Cloud Build. Google Cloud Build will build the file, will deploy this into the artifact registry, and then we will see a success. Now, I will jump also to Google Cloud in the meantime. And let us look at build. You see here that 11 seconds back, a new build was triggered. And while this build runs, while the GitHub Actions, the workflow completes, what we will do is I will go into the source code and I will show you how this action has been defined. So this is my source code, and this is a specific workflow that is running right now. This has been defined in .github workflows. What we're doing is on the event, when a pull request is either opened or reopened, we will be checking the code out. We will be, and I will zoom the code a little bit more. We will be authenticating with Google Cloud. We will be setting up the Google Cloud SDK. And finally, we are pushing this code to Google Cloud Build so that the image is built and it is deployed onto the artifact registry. Finally, we will use an action from the marketplace to write a comment into the pull request. So this is the action that we have defined. Let us go back into GitHub and see where we are with this. So this has already completed in under a minute. We see that it is successful. It has been built. And when it builds, you will see that all the tests are run. And this is where we see that the tests are successful. And hence the final image has been built and has been pushed into artifact registry. Okay. So this is the first part of it. I will now switch back into the slides to demonstrate the second part of what we're going to do. Now, this is a continuation from the first scenario. What we have again is the same source code, but this time the source code, the pull request has been reviewed. The developer or the maintainer is now going to merge this pull request back into the source code. We will again trigger a GitHub action. This time, we will authenticate with Kubernetes engine on Google Cloud. This will then talk to an existing Kubernetes cluster that is already present. It will deploy the image that is present in the artifact registry into this cluster, essentially updating all the images that are running on this Kubernetes cluster. So what we're seeing here again is that the code has been tested, compiled, the code is brought into the main branch, and the code is now deployed back into the development environment where everyone again is working with the latest code base. Now, this approach is something that is interesting because, as I showed before, when you have a large application, it will take a lot of time to build the entire application, to probably spin up a brand new cluster, and to push all the images into the cluster. So what we're doing here is we are having a cluster that is already running, and we're going and updating the image within that same cluster. So only that image which has changed is rebuilt and pushed into the cluster. All right, I will now switch to the demo. Good. Going back into the pull request that we just created. So the pull request is now ready to be merged. So here I will again just merge this pull request. We will confirm the merge. What we also see here is that from the last step, a comment was entered into the pull request. So we know that that action was also completed successfully. Now the code gets pulled and merged immediately because, of course, it has been tested before and it can be merged into the main branch. However, the action will now trigger again to deploy the latest version of this code into the Kubernetes cluster that already existed. So here you see that this workflow is now running. While this is running, let me again show you how the build works if you introduce a breaking change. So I'm going back into my source code this time. Let us go into the test. And let's go into the feature branch, of course, because that is the workflow we have defined. And I'm going to be changing this to something else, right? This is not what we are expecting out of the working code. And I will commit this to the feature branch. And like before, I will now create a pull request to merge this new change. Of course, this is a breaking change. All right, so the pull request has been created, and I will jump back into the action that we had before to see what status we are. The action just completed. And here you see that this image has again been compiled. We have used the latest code from main. We have built an image. We have pushed it to artifact registry. We have connected to the Kubernetes engine and deployed this latest image to the existing Kubernetes cluster. So that is what has happened here in this workflow. And I will go into Google Cloud to show that this has been done. So this is the new build that's running from the breaking test case. And if I refresh the artifact registry, we will see that a minute ago, we had a new build, and this build is successful. Now, the artifact registry also helps by scanning all the images that are present here for vulnerabilities. So we can use things like binary authorization to ensure that only images which don't have any vulnerabilities are made available in production. So these are additional benefits that you get. And if I now go into Kubernetes, in fact, we can see that on the GitHub action itself, in the deploy step, we will see the external IP where the service was deployed. And let us open this. And this is the latest change that we made. So you see the latest change has been taken up, has been pushed, and is already live in the development environment. And now if I go back into the actions, you see here that the check has failed. This is where I had the breaking change. The check has failed. And if I go into actions, look at this change, we will see that it failed at the point where the cloud build was called. So cloud build failed, and again, it failed because of failed test cases, right? We had a failing test case. So this is an example of how your development pipelines can be built. And all I'm doing is focusing on the code, focusing on the tests. I don't have to do anything with respect to operations, with respect to running the test, automation, deployment, and so on. And this is the power of GitHub Actions and using Google Cloud as well to set up the workflows that you would like to have. I will cut back to the slides now. Awesome. So in summary, I would just like to leave you with a few key takeaways. We spoke about this before, but to reiterate, use a high quality, robust source code management system, adopt containers to build images that are consistent all the way from development to test environments to production environments. Test, 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 and write more and more tests. This is super important. Automate everything that you can and build CI/CD pipelines to make your job easier as a developer. And finally, a couple of additional things. Try to find a build system where you can save your build configurations along with your source code. So this way, you know when something breaks, that it is your source breaking or is it your build configuration that's breaking. This will also help you actually build these automations. And finally, leverage some of the capabilities in the platforms that you're using. For example, the artifact registry, which automatically scans for vulnerabilities that I showed. So with that, I come to the end of this demo, end of this talk. I hope I've left you with something in terms of how you can build your CI/CD pipelines, how you can use GitHub Actions to automate your workflows. And if you have further questions, please connect with me offline on social media. I'll be glad to help you. And with that, thank you for your time. Thank you for this talk, for spending time with me on this talk, and hope you had some good takeaways. Thank you.
Wow. Thank you, Prashant. Thanks for educating us on like how you can use CI/CD with GitHub Actions and Google Platform, right? That's a very good one. But another key takeaway that I want developers to consider is like the power of choice. I think our leaders have reiterated many a times that developers are the center, right? Developers are the boss, right? It's developer first. Even in this demo, if you imagine, like you always have the choice of GitHub CI, GitHub being used only for repository management, or using a combination of GitHub plus Google Cloud or any other providers, right? You always have the option. That's the power of choice, right? Please do consider. I heard that there are some tweets coming our way. Richa, are we ready?
Yeah, let's look at a few of them.
All right. Ashish Chawla. India is leading the fintech revolution with a huge digital ecosystem. He's quoting Nandin Nilekani at GitHub Constellation. Thank you. Thank you for that. Next tweet,
That's
please.
definitely true. And let's have another one. We have one from Carrie Cool Dude. This one is about the open source and community being the key to code building initiative, India initiative from scaling the project to the product.
Wow.
And the startup journey. I think again, I'll talk a little bit about what we heard from our keynotes yesterday. That open source has won, and really, it's a very interconnected world today. We all, as developers, are even further empowered because we can depend on what each of us is building, and we can build on top of it. And so it's really great to see that open source culture thriving. Thank you again, Carrie
That's not
Cool
fair.
Dude.
That's not fair, Rich. I was planning to quote that.
Oh, okay. Sorry, I took that from you.
Anyway, I think we have one more quote. Shivansh, what does the CEO of GitHub and I have in common? Wow, what's that?
Yeah,
Passion
we want to know.
for
Great
wow, well
one.
said. Well, thank you. Please keep the tweets flowing, right? And do remember that the
You
tweets
can
that are
bring
being
some
showed
cool
here,
swag.
like you will get some, yeah, you get some cool swag, right? Try your
Yeah.
luck. Yeah.
So Diwakar, it's amazing to see how the world has become so connected and the role that social media platforms are playing. Sometimes I feel very old, because I feel like I'm still getting used to that, while the next generation has learned how to use it to their advantage. And talking of the next generation, and in the context of the last few years with the pandemic, uh, Divakar, how have your children been doing with online schooling?
Oh, I was trying to forget all about that, Richa. Thanks for reminding. I have two naughty boys, and this
Mm,
pandemic has been awesome, right? In a way, because if you think about, if you ignore the negatives of it, of course, it did bring in closeness among the family members. We got to spend more time with the kids, and if you think about the tech part of it, my younger one is using Microsoft Teams, and he keeps checking
yeah.
with me on like how I'm using Teams and how his Teams is better than mine, because he gets
Ah,
to submit assignments through Teams and I don't get to,
assignments.
right? Unfortunately.
Yeah.
And they also ask, how many sparkles I got in Slack. And once they even keep count of it, right? 280, 290, whatever. For those who don't
Yeah.
know, sparkles is a friendly way of acknowledging someone for
Kudos.
their contribution, right? It's like a kudos, like it's a pat on the back, right? So we have in GitHub like the sparkles, and my kid keep tab of the counts, and once he shouted from my workspace all the way to the living room where his mom was there, saying that Daddy did not do any good job today, no sparkles. Anyway, it's all fun, fun, fun. Yeah. So what's up with you, Richa?
Yeah. So I remember you mentioning that you folks had started, using Duolingo for learning some
Oh yeah,
languages, and
right.
and I love Duolingo too. I've been using it to learn Spanish. My kids are learning it, and I'm like, I'm not going to let you have your, secret language. I'm just kidding. It's a lovely language, and it seems so easy to learn. Perhaps Duolingo makes it easy, and I believe Duolingo is on GitHub.
Yes, I was about
So
to say that. Yes.
exactly. And so talking about these past few years, and yeah, while it has had its own challenges, online education, I feel like it's opened up the doors in many ways as well, right? Making it a lot more accessible. Like children are learning things from teachers who are not in the same location, like even music and learning instruments. It's quite amazing. And something else that I've noticed is that, even though my kids may be spending a lot of time playing video games, that's another challenge. But they're becoming aware of a lot of things, what is security. They're also learning to learn, becoming appreciating what effort it takes to build and run software at scale and reliably. They were complaining the other day when their favorite video game platform was down, and I think they were easily able to connect, when my team or I are heads down fighting some fires in our own service. So people learn when they are immersed into a situation and when they experience problems firsthand. So, and I think GitHub sees this as an opportunity and a responsibility to help the next generation by giving them some great tools and, programs to guide their learning. Just reiterating what Stormy said earlier, that if you're a student, do take advantage of the student developer pack or tell students near you about it. And stay tuned for tomorrow's session, which is going to be all about education. So coming back to today, Divakar, have you heard the term observability?
Observability. Wow, that sure sounds like a $10 word that I can remember and use somewhere. What is it about?
Well, that is what we're going to learn next. So, up next, we have a panel discussion on observability. We have folks from Traceable AI, Signos, and Elastic. So, over to them.
Wow.
Hello everyone, welcome to GitHub Constellation. And today we will be doing a panel discussion on observability in DevOps and open source. And we are joined with two of the panelists from the observability community itself. Hello Pranay and Arvind. Pranay, do you want to introduce yourself?
Yeah, sure. Hey guys, I am Pranay. I am one of the co-founders at Signos. Signos is an open source observability platform. We help developers monitor applications and troubleshoot any problems. Basically, an engineer by background, accidentally got into observability domain and enjoying it a lot. So looking forward to the discussion.
Hey, hi Jayesh, and hello everyone. I'm Arvind, and I work at Elastic as a developer advocate. So yeah, pretty similar things: observability, DevOps, and also a bit of search. Yeah, excited to be here and probably talk to you all more about observability. Yeah.
Thank you. And for all of you out there, I'm Jayesh. I work at Traceable as a product manager. And I'm co-creator and one of the maintainers of Hypertrace, which is our open observability platform. So have been in observability since last couple of years and exploring some of the interesting things. So we will talk about many of them today as well, and we will have some of the interesting opinions, questions, answers, I guess. So starting with the very first one and interesting one, what is observability? And Pranay, what is observability for you?
Yeah, so that's an interesting one. So I'm an electrical engineer by training, right? And in electrical engineering, you always deal with systems and how you can understand what's going on there, right? So to me, observability is figuring out what's going on within a system through monitoring the external outputs, right? And so the observability broadly as such is independent of software. It's just a concept that if you have a system, how do you figure out what's going on within the system? Monitoring the external outputs, right? Though this term has been made a lot more popular with the software systems, and which is sort of the context we are discussing in, and more especially to software systems, I think observability is figuring out like what's going on within your software stack, within your servers, within your infra stack, by monitoring metrics, logs, and traces, right? So I have sort of a weak definition of observability. So anything which helps you understand how your system works, what its bottlenecks are, where it's possibly failing, and potentially how you can like solve it is observability for me.
Definitely, and like that's a pretty interesting and well articulated way to put it, right? So as I have been going through those definitions and understanding for me like what observability is, uh, I try to articulate it like the capability which just enables you to ask questions about your system. And when we talk about metrics, log spaces, which mostly people talk about while talking about observability, it's more of a way to fuel those answers. So it's a way to get the data which can help you answer those questions about the system. But yes, as you pointed out, it's a capability which just lets you ask questions to the system and get answers whenever you want. So, Arvind, what is again observability for you?
So to be honest, like I tend to agree what Pranay was saying. And then I have heard this term like, maybe 3 or 4 years back when it's getting popularized. But it's a general concept, and I've always heard about the monitoring aspect of infrastructure and how do you monitor things, profiling, coming from Java background. And then like people started to add more like logs, metrics, traces, which is all there. But when you put together, and you will start to realize that the pitfalls of what's happening when there is an issue. So that way, I think observability is like getting to know your infrastructure from a 360-degree point of view. It might be a single data point that you could take and like try to cross reference or check or like get to a RCA. So that's how I personally see. But over a period of time, it's not just logs, it's not just traces, it's more. I've seen that observability as a standard is evolving, and then lot many data points or things are being added to it. So that way, I think it's ever evolving as a definition, and it's going to add more and more tools in the hands of developers as we go through.
Yeah. And definitely, it's not just about application. And as you rightly pointed out, it starts with your load balancer and goes till your backend. Whatever happens in between and whatever happens on the both ends, everything, keeping track of everything, maintaining that context and the correlations, uh, it all helps in the greater observability in general. One of the thought I came across recently was systems are by default opaque in nature, and observability is something which helps you compare the systems as imagined and the systems which are observed, like systems as we observe them. So going towards the next one, as we're talking about, we all have been working around observability since some time now, and mostly we worked with few customers, few came across few use cases during the our tenure, right? So, what are some of the interesting use cases or customer needs you came across while working around observability?
So I could start because I've seen some interesting trends in the recent times. Is like the borders or the lines between the observability. I mean, when you start talking about observability, usually you tend to think about the DevOps practitioners, maybe developers who are like building and trying to work with the CI/CD system, all of that, right? But I also start to see a lot of SecOps people also try to use the same data and for their analysis and trying to figure out things. So I think the observability and the security area is merging, and a lot many companies are really taking this data or like really taking this trend towards making it easier for a lot of security practitioners, infosec folks to like easily build and analyze data. So as we become more and more digitally transformed in the terms of like each and every process, I think this would be an interesting trend to note. Maybe security will become more focused. So than what we were talking about, usually about observability. So yeah, so that's what I'm really excited about and see as a trend.
Definitely, and as I have been working on that intersection of security and observability since 2 years, it's very interesting to see that viewpoint, right? And even one of the payments company we were working with, mostly for observability part of things, they eventually started using the same data for detecting DDoS and the other attack types as well. So it and using the exact same instrumentation. So it's kind of helping towards the security aspect of things. And we at Traceable have also been working around some of the use cases specifically around security. And one of the interesting use case apart from security I came across recently was for like business metrics. So one of the streaming platform we are working with, and they have a payment gateway, obviously. The payment gateway has different payment providers, and they want to know if some payment provider fails. If a phone pay stops accepting payments, or phone pay payment starts failing, or some other payment provider's payment starts failing, they want to be alerted on that and want to close that payment gateway as soon as possible to just avoid the failures in general, right? And that becomes a very good point where you have this data, where you have this metrics, these traces which are coming and giving you all this context, and you can use it for different business use cases as well. And that's one of the part where I see this data is being used and the business use cases which are being addressed using the observability part of things. So, Pranay, what are the interesting things you came across?
Yeah, so I think we are seeing the observability like domain itself evolve a lot. One of the things which I'm noticing is observability is sort of shifting left, as in like more and more developers and like individual developers are really looking to understand like how their systems are working, right? So, for example, some of our users, they are using signals to monitor their front end applications also, right? Like though like traditionally we think observability to be only focus on backend, but people now want to see that hey, like how a trace goes from front end to load balancer to backend, right? So growing, I think as software systems are getting more complex, right? We are seeing that more and more people are interested in learning how these are behaving, and I think it's also important that they understand how things are going, right? I think the second thing which we are recently seeing is that people are becoming a lot more privacy sensitive in the sense that they want to understand like, hey, where is the observability data stored? Is which servers are it going to, right? For example, one of the users who is using Signals, they are a fintech company based in India, and RBI recently had a regulation that, hey, like if you are a fintech company, you can't send PII data outside, like in outside servers, right? Something like that. So that sort of push that, hey, like if it's observability data is important, and then we can't store lots of this in like we need to have control over where this data is stored is like one of the things which you are seeing, and which is pretty interesting to me. And I think this trend will sort of go like more become more important as like countries become more sensitive about their data, right? And these are like the couple of things. And like what you're seeing is like more broadly what you're seeing, there's like a whole influx of new companies who are investing more in setting their observability well. For example, there are like games company which use Signals, and like because they have very high sort of throughput which they want to monitor, right? And that's why like, they sort of go for an open source product like ours, because like otherwise like SaaS vendors etc become very costly, and they can sort of control how much they like what type of servers they want to run in. They don't have to suffer latencies etc by sending data to cloud, right? So yeah, so broadly seeing lots like observability being used by lot more type of users, and then also uh, sort of every part of the organization, like from developers, even front-end developers are now interested in learning about observability.
As you mentioned specifically around open source, so what is your take on the open source observability landscape, which has been evolving quite a while since last few years? We definitely have came a long way from Nagios, which we used to have in around 2010, 2009, right? And but what's the story today, and how the landscape is evolving these days?
Yeah, so our view is that because observability is like observability products are being used by developers, right? So our view fundamentally is that if like the developers are your end users, open source just makes more sense, right? Because if I'm a developer, given the quality of the product is like comparable, many times people, like earlier used to be that like open source products were not as good as like sort of like closed source products. But now we are seeing uh, that open source product quality is becoming more important. So to us, it seems that like if you're a developer and you have to choose a product, right? You by default you should choose open source, right? Because you can see the code, you can integrate it in your applications more closely. You can sort of uh, more tightly customize with your CI/CD pipelines, etc. Right? And also be part of the community, right? So it's not just about using a particular product. If you find something great, you can, and you try to fix that in your system, you can contribute back, right? So fundamentally, the way we think about it is that like products which are used by developers, DevOps engineers, etc., would would see a huge jump on users of open source products, right? Like people will by default go to that rather than just using closed source vendors, and and the landscape as a whole is like maturing very rapidly. I'd say there are like lots of great products in the domain which people can now choose from. I think all three of us represent products which people can try and see what fits well for them, right? And I would say the quality of the products available in open source is pretty great, especially in our domain. I think open telemetry has done a great job of sort of commoditizing the instrumentation layer. So now projects don't need to worry about what they will use to instrument. They can just build, like rely on open telemetry as the instrumentation layer and sort of focus on providing value to the users, right? Like what sort of UIs, what sort of the interaction should be enabled, what can be how you can efficiently store data. And like that's the sort of approach we are taking at Signals, that hey, like open telemetry sort of instrument solving the instrumentation layer, but like how do we add more value to the user through like building a great front end, building a great back end, and making that as simple as like a SaaS product, like which is out there, right? So yeah, so broadly very bullish about open source landscape in this domain. I'm sure like the product quality in open source will become very important, very like improve a lot, and then I think open source will be the default thing which people start with rather than a closed source vendor.
I can see that the adoption as well as trust around open source is building, and there are a lot of, as you mentioned, a lot of open source observability products which are very mature these days, and specifically around open telemetry, right? The democratization of data collection and the simplicity it brings in general, and the vendor neutral way of doing it. It definitely helps people to easily instrument the applications, and also don't have to worry about uh, they might change a vendor one day, and then or a product they are using one day, and they won't be able to get as much of the value out of the previous instrumentation they did.
Yeah,
And
and it's
at the
just
end,
higher
it's
level of trust. Yeah, I think it's just higher
yes,
level of trust, right? That hey, like as a developer, you want to know like what's running in your infra, and like this is something which
correct.
like very many of our users tell us that hey, uh, like I want to because these are also developers, right? Like they know
Yes,
like what code is and what, and they want to learn like what's running. They don't want to be engulfed in a black box thing, right? And that's why it's very important to get that trust that hey, this is the product. I can see what is inside it. If the quality of the code looks good, I can use it. I can actually even fix it if there is some issue in the code, right? So I think that sort of being open, being able to provide that sense of trust is very important, I think. And that's why we are sort of seeing like a swell of open source adoption. And I think this trend would continue.
definitely. So, Alvin, what's your take on the whole evolution of open source observability landscape?
I think it's exciting. A lot of projects have come in like in less time. Open telemetry with the the merging of all these open sensors, and the total project itself is a great standard to follow on. And I believe that if it really works out, it's going to bring in a lot of change in what everyone is trying to do at this point of time. I think there are a lot of SaaS observability companies, and eventually there will be a lot of enterprise adoption of all of these. And then I think especially in the open source area, that is going to be interesting from one point of view, from a standard point of view. And then there are these discrete popular data stores, right? The Prometheus, and then you have these like the Victoria Metrics. There are different like ClickHouse again. So each one of these like are kind of like serving as a stores for a lot of people to build customized solutions on top of it. I have seen a couple of DBs people built event stores using a solution, like putting it together as a solution. That itself is really great. I guess we also have one more popular project from LinkedIn. I really forgot the name, but then I think that's interesting as well. So there are many of these open source projects which are not exactly like the straight in replacement for any other database, but then together each one of these from open source modules would make a great DB or great solution for observability. And I think that's where we are heading from the open source point of view as well.
Absolutely. And as you rightly mentioned, there are so many problems around this space. It's the hard problems, easy problems, but there are so many problems in place. Even starting with the just metric store or the trace store, uh, the storage becomes one of the important problems. Then the analytics becomes one of the important. Visualization becomes one of the important problems. So there are so many interesting projects which are coming into picture, which are solving these problems in silos. But at the end, when it all comes together, it becomes a very good and insightful, contextualized thing which people can consume and solve their problems with.
I would like
So, definitely,
Jay, sorry, I would like to add one more thing here. Like you rightly pointed out, I also see some specific companies, like when you say Polar Signals, I think in recent times they are also open sourcing some of these data stores, whatever the models that they are following, which is also very nice in a way, because it's not like they're having a columnar store internally, and then they are keeping it proprietary. But from the observability standpoint and open source standpoint, like it's good to have more in the open and transparent with whatever license they may be. But then that is really nice to see, in my opinion.
Arvind, can you name few of the projects you came across?
So I think there are many. I mean, nevertheless, like you always have CNCF projects, and then like the Prometheus, and then OpenTelemetry are good starts. Even though they are big, but then you will find a lot of tangents to work in. Like you could go and work on the Java side. You could go and work on the Rust side, which is like probably a bit more contributions are probably needed there. So there are a lot of these that you could build parallelly, if you want to take a look at. There are see, I think like every week or every quarter at least, I see one or two interesting projects. For example, one that I just pointed out is the Polar Signals one, where they have open source their approach of like how they want to store the events or data in a columnar store. And so that is a good one to look at as well. But I think foundation-led projects will give you greater access to every in the network from the career point of view, and also make it interesting for you to work with other foundation projects like Kubernetes and etc. So I think some of those projects are what I would like to know. But in the interest of everyone in the panel, I'll also tell that Signos is an open source project, and you might want to look at, and Hypertrace is also one more. So each one of them are interesting if you just want to learn or take a look at them as well.
Thanks, Arvind. And you clearly articulated many of the important ones, I guess. So, Panay, do you want to add anything to those?
I think Arvind had a good list. I think one project which I am sort of following is Cilium. So this is a EPBF based project which is trying to not specifically solve observability, but they are into like monitoring, networking, and observability as well. The key thing it does is that it enables you to get metrics from the Linux kernel layer very easily. So rather than you trying to instrument all your applications with like a bit of code and then getting the data, you can sort of enable certain flags and then start getting those data, right? So I think that's one of the projects which I'm keenly looking in, and like we'll see like how we can think about adding that to Signals, or like some parts of that to Signals. But yeah, like very excited about like different DBs which are coming about, which are like specifically for observability. And I think that's like, these are like great project we should be looking into and like learn more about.
eBPF is definitely one of the very interesting things, and I was trying to avoid that in the conversation because of the avenues it opens. But yes, as you mentioned, like the people who want to
Unfortunately,
check
I
it out,
did.
yes. So people who want to check it out, definitely go ahead and check out the eBPF thing as well. It's evolving pretty quickly, and it's getting whole thing in a very right direction, I guess. So finally, like as we are coming towards the end of this discussion, what would you suggest that companies who are just getting started with observability should start with, or get started in the initial phases?
Yeah, so maybe I can go ahead first. I think one things which we are like sort of recommend all our users, like anybody who sort of asks for advice on observability, is to look deeply into OpenTelemetry, because we are seeing, like, we are based on OpenTelemetry for the instrumentation layer, and we're seeing that the project is evolving rapidly. So, and because it's an open standard, like that sort of enables you to plug in any backend in the end, right? So for example, you can start with Signals, but if you don't like us, you can do uh, Elastic or any other sort of tool, right? So I think if you're starting today thinking about observability, look deeply into OpenTelemetry, look what it can do for you. And I I think mostly like 70 to 80% of the stack is like fairly mature now, so you should be able to get a good handle on that. And so that sort of makes you future proof, right? So rather than you getting locked in a particular vendor and then like being stuck with their instrumentation code in your database, and then or in your applications, and then not being able to get out because like you have incurred so much like development debt on top of it, start with an open standard. See where it may not be like perfect today, but it's maturing rapidly, and then you have the flexibility of like switching vendors if you want, and just being able to see the code, right? So that's one. And I think second would be to evaluate if open source projects which are coming up are able to serve your needs, uh, because as I mentioned earlier also, right, that if you're a developer, if you have an open source project which is of the same quality, right, and generally that has been the concern, that like the open source projects were doing a piecewise job, but if you're able to get something which does what you want to do, I would suggest to start with that, even though it might be like a bit of more effort in the beginning, but I guess it would pay out in the long term, and it would also uh, like help grow the open source project and like contribute back, right? So it would just also be like much better learning for your developers. So I think those are two things. Start with open telemetry, check if the open source projects which are there today can be good fit for you.
Absolutely. I usually reverse this advice and start with first understand your goals and what you want to do with the whole thing, and what you want to understand about your system really, and how it will serve. Eventually, go start small. Start with open standards by default, and instrument one service. See what insights provides you, and eventually go start peeping into other parts of the systems as well. Uh, but yes, and Arvind, so what will be your advice for people who are starting with observability?
I would say exactly kind of advice that you were also saying. Renee told a lot about tools and various projects that are there and how you could look forward for the long term TCO, a lot of these things. But then I would recommend, if you are thinking about observability, monitoring, whatever it is, just start a Google Doc or like a paper. And if you are the product owner or product manager or a developer, start looking at what are the top 10 metrics that I really want to know, and how is my data currently being collected, or what should I want to do with that? Like, should I throw away that and start fresh? So these are the questions, like how do I collect, and then what data should I need to pick them up, sanitize, what is the process like, and then what are the top 10 metrics that I want to monitor. If there is a issue, do I have already a dashboard or an alert or thing to look at? I think the tools, databases, solutions, technologies, SaaS platforms, open source projects, everything comes second, because once the business is in problem and you are incurring loss, all that your boss wants to do is like get that up and running. What, I don't know what it takes, please get it done. And at that point of time, you will not have time to look after all of that. And I believe the best way, and people usually retort to the SSH and then trying to figure out things by themselves. So I would recommend always to start from this end, and then you could eventually end up in one of these areas. Like, obviously you will look at OpenTelemetry or Prometheus or like any other Elastic or any other project, right? So I think that is what I would recommend any developer or product owner to look at. Figure out what you really want to do. And there is also a saying, like, there is something called mean time to detect and mean time to react. So you need to focus on, like, how do I get that mean time to react a bit better and faster. SREs know this very well. So yeah, that's my advice.
Thanks, Ivan. And that was a very good articulation of everything, I guess. And that was it from my end. That's all. That's the all questions I had around observability, open source, and the community aspect of things. And I definitely think there's a great community support backing the good projects around observability in this age. And there are so many amazing people who are working together to solve this problem and making systems observable every day. So I think it's a great state to be in, and we will see how the future evolves and what different use cases, how the what different applications we will see in the coming days as well. So thanks, Pranav and Arvind, for joining in, and looking forward to uh, having this discussion even on even a wider note in the coming years, and we will see how this whole evolution looks like. Thank you.
Sure. Thanks, Jayesh.
Thank you.
Bye-bye.
Bye.
Wow, that's a wonderful panel discussion. I'm really glad that these companies are working on this observability concept. Boy, that's a mouthful of a word for me. It reminds me of the good old developer days when we had to struggle for crisis management, right? Like, we had tons and tons of log files from disparate systems, and like we had to tie it back together to make sense of it. Oh my God! Like, it sounds as if like it's too good for me to believe. Maybe I need to research something on it, but it's too good to believe. And if this thing works, this will actually make the developer life easier. And like anyone who is part of the SDLC, right? It looks like even businesses can make sense of the usage. That's very nice. I was trying to research more on it in parallel because there was no demo in this panel discussion. Like, it looks like Signos.io, one of the panel members' website, like had a quick demo of like how things work. So maybe people can go check it out. And one more thing, I don't know if you noted, Richa, like Pranay's quote, increased trust with open source, right? That's amazing, right? Like, if someone told me about this statement like a decade ago or something, I don't know, like whether I'll be laughing or whether I'll be wondering. But things have definitely changed when it comes to open source. Like, now people are thinking that, if it's open, it is trustworthy. Amazing. That again reminds me of the statement that you quoted earlier: open source has won, right? On a lighter note, I was wondering, like, Arvind, like he's all locked up and he's like all bolted, and I was wondering, like, who he's hiding from. Maybe I'll have a private chat with him. Like, I don't know if it's the pets or the kids. Thankfully, I am nicely hiding in an office space. So,
Good
Richa, what's
observation or observability skills, I would say. So yeah, coming back to our sessions. So in the next session, we are going to hear from Kanika Pasricha, who is a program manager at Microsoft. And she will be covering the OIDC protocol, its relevance to security, and how we can leverage it to access Azure resources from GitHub Actions. And don't worry, even if you're not very well acquainted with GitHub Actions or authentication and authorization protocols, you will definitely find this session quite insightful. So over to Kanika.
Hi everyone. I hope you're all doing well and having a wonderful time at GitHub Constellation. Let me take a few seconds to introduce myself first. My name is Kanika Pasrija and I'm working as a program manager in Microsoft. And I'm really happy to say that I'm an ex-hubber. So basically, I've been proud, happy, and very wonderful journey to be in a part of both these wonderful organizations, GitHub and Microsoft. So now talking about Microsoft, we think about Azure. And yes, you guessed it right. This session is about accessing Azure resources using OIDC in GitHub Actions. Need not worry, I know a lot of terms in the title, Azure, OIDC, GitHub Actions, but there is no hard prerequisite for you to understand this session. We'll go through them step by step, and rest assured, you will be able to have some good knowledge from this session. So let's talk about the first term in the topic, access. What is access? Whenever you're trying to access anything on the internet, may it be your Instagram reels, your Facebook photos, or anything, there are a lot of things involved. Some security concerns, some validations, a lot of protocols into the picture. So let's try to understand just two basic terms which often lead to some confusion. So we'll start the session by understanding some basic terms. And yes, as you can see in the title, OIDC, GitHub Actions, and then we will actually see one wonderful scenario how we can access those Azure resources. Coming back to the terms, those two terms are authentication and authorization. What these terms actually mean. They cannot be used interchangeably, obviously. So authentication basically answers to the question, who are you? You know, it actually checks whenever you're trying to log into a system, are you the right user to access those things? So that is authentication. But even if you're the right user, do you have permissions to do the activity that you're trying to do? That is what we call as authorization. So who are you is answered by authentication, and are you allowed to do that is answered by authorization. So let's take a very common example. I hope you like to travel. And if you like travel, you might have visited the airport multiple times. What happens when you actually visit an airport? There are certain security checks, right? Not just internet requires security check, a lot of all the other things in life too. So when you're entering the airport, there are certain checks. One of the check is when they actually see your ID to see who are you. And not just that, they actually match it with your face. Sadly, nowadays we have to take our mask off to show a real face. But yes, that's the process. So they actually see whether you are the right person who is entering the airport, who has actually booked the flight, and you are the one for whom the flight has been booked and everything else. So that is called authentication, to ensure that who are you and are you the right person boarding the flight. So once that is done, you are issued a boarding pass. So after your luggage gets checked in and things slow, when you're entering a flight, they don't check your face again, right? But what if you enter a Mumbai flight instead of a Delhi flight? Then there's some twist in the story. So that is why we need to ensure that you have the rightful permission to onboard to that flight. That is what we call authorization, where you actually show your boarding pass and they see you are entering the right flight. You have those permissions to do that. I hope next time you're entering the airport, this authentication and authorization sticks with you, and not just for flights, but for understanding all security protocols of internet access. This is about understanding the basic terms which we'll use today. And now, in the title we heard, there were a couple of more terms, GitHub Actions and OIDC. Let's go through them one by one. So some of you might have used GitHub Actions before. Some of you might, something new, maybe just heard, never used. So just to avoid that blocker for you to understand this topic, I'll just give a very brief overview what GitHub Actions are. So GitHub Actions is basically a platform which is provided to us by GitHub for continuous integration and continuous delivery. Yes, CI/CD. So if you see any workflow involving GitHub Actions, there are a lot of things in the picture. There is an event, which is, you can say, some kind of a trigger, something that happened. And then on the basis of that, you want certain activities to take place. So let's take very common example. You maybe just push your code into the repository. And now you want certain unit tests or maybe certain integration tests to run. The event will be whenever you push that code, and then there can be an action or a script that can run on the different runners. So by runner, I actually mean, some different environments. You might want to run those tests on Windows OS or maybe Linux OS, those concepts. So running action means basically calling a function to do anything. And just, as basic fundamentals of function, we pass certain arguments, right? Here also in the action, there's a defined signature, whatever parameters it requires, and then those are passed with the action call and those steps can be executed. So that is how on a high level action workflow looks like. Something happens, something is to be run, something is to be passed, and then you receive your something result. So this is what GitHub Actions are. Next, as I mentioned, we'll understand what OIDC is. So I'm just covering these 2 to 3 terms in the beginning so that it becomes easy for you in the session. What is OIDC? So, and now I know you're very aware, very much aware of what authorization and what authentication means. So OAuth 2.0 is a protocol which actually, lets you implement the authorization part while accessing anything over the internet. But as we understood, authorization is good, but not good enough. So we have a thin layer, which is called OIDC, OpenID Connect, which sits on top of OAuth 2.0 protocol and enables us to implement authentication along with authorization. I'm not going into much details in terms of security policies and their implementations, but don't worry, I'll definitely share the good resources which you can go through and understand these concepts in detail at the end. But this is, again, I'll share the resources, but authentication, authorization, and OIDC is something that, you might be interacting with it on a regular basis. Let's see how. So I'll actually use, understanding OIDC flow concept. How does it look like? So let's see, nowadays what happens. There's so many applications being built up, doing a lot of things, some creating animations, something doing some random videos, some creating any kind of magic, right? It's all out there. But for every application, do you need to actually create separate login credentials? Do you do that? For any random app you interact with, do you create again a username, password? I don't, and I hope you don't, because you get the concept of, login via this, login via this. These are all these available to you so that you need not create separate credentials for all apps and meanwhile access those apps in a secured way. So let's take a basic example. And before going to the flow diagram, let me just tell you what these different components are. Resource owner is you. By you, I mean, just you. You can own different things on the internet, maybe your photos, your videos, your songs, not just that, your contacts, your friend list, your messages. All these are resources which actually just belong to you. And then there's a client application. For here, I'm considering, say, maybe any application as we talked about. Let's take an example, my photo app. This app, I say, is actually, takes your photos and creates a wonderful video for you. So my friend's birthday is coming. I want to put up a social media post of videos, but I have all my photos in Facebook. What will I do? Client application, my photo app needs access to Facebook, but I'm not comfortable in giving my Facebook credentials to my photo app, right? So I'll use login via Facebook and give them, Facebook will act as my authorization server. So an authorization server is a server which will actually authenticate me and authorize the client app and give the access to proper resources. So once you click in via login via Facebook and enter your Facebook credentials, then there's an exchange of token that happens. And primarily of focus, there are 2 tokens which are exchanged, ID token and access token. As we discussed, OIDC is about 2 things, authorization and authentication. So ID token and access token are serving those 2 needs. ID token actually ensures the authentication. The right user is accessing those resources. And authorization is for the permission part. So I just want my photo app to take my photos and create a video out of it. But I don't want my photo app to post on my behalf. Or maybe send friend requests to someone. No, that's not the permission I want to give. So that is handling the authorization part, for which is controlled by the exchange of access token. These two tokens are exchanged, and we, can safely access the resources well over the internet. And I hope this actually gives you some glimpse of what is OIDC flow, what are the security concerns, and how things are handled over the internet. Next time you're actually clicking on login via Facebook, you know what is happening on behind, how your things are being shared. I'm pretty sure you might have seen that screen where it asks you, this application is asking permission to access your photos. Do you agree? Do you not? Yes, that's all coming because the access token has predefined permissions, and the third party needs those permissions from your authorization server. So this is about understanding the OIDC flow, and I hope now it's started to build some picture in your head. So far, just a glimpse, we got to know what is authentication and authorization, the airport visit story. Next, we understood GitHub Actions. When the developer wants to push something, certain tests have to be done. And now this login via Facebook, which you actually very regularly do from day-to-day life. So next, now try to understand what is the scenario for accessing Azure resources via GitHub look like. Not many times we keep on doing this, but let me introduce you to a friend of mine. So this friend is named Coco. Hi, Coco. Coco says, hello world. So Coco is a developer here, and Coco's team has a web application which is deployed to Azure. And that application can be accessed via some credentials. I am sure you might also have some of those Azure applications for you. So now Coco's team keeps working on that application, and they want the application to be up high and running every time. So they have built some test scenarios, and they want to set up a GitHub workflow, which ensures that all the unit tests and integration tests are run properly. If you remember, there's the GitHub action workflow. I took the same example. When you push a code, you want tests to run and ensure things are done properly. But this is okay. Coco can do it. How? Let's go through it. So Coco has a GitHub workflow. As I mentioned, there is certain event, which is a trigger, and on the basis of that, certain actions are expected out of it. So now, since Azure is involved, there are some access restrictions, right? GitHub has a different workflow platform, and I have my services on Azure, which has different security constraints. So if you're an Azure user, you might know that something called app registration or an SPN, which actually provides us very important credentials, which is the client ID and the client secret. So login action is one of the GitHub actions provided to us, in which from the workflow, we can access the Azure resources. So just going by the terms which we used in understanding the OIDC, there's a client, which is the GitHub workflow, and there's the authorization and the resource server, which is Azure. Because Azure will authenticate, Azure will provide the right resources, right? So now the Coco can use the login action, pass these credentials, client ID, client secret, tenant ID, and subscription ID. So these credentials, I hope you know how to create those using SPN, or you can actually go to the Azure portal and create those credentials. Need not worry, even if you haven't done that for the first time, I'll definitely share the resources, the step-by-step guide to do that too. Once login action passes these credentials, just like any application, these credentials act like username and password, and we say, woohoo, that's done. Access is granted. And next, the GitHub workflow can access the services, the resources, and test strategy, or anything they want to implement that can be done. So definitely, in our scenario, the process is complete. But there are certain concerns, So client ID is there, client secret is there, which are being, if you remember, 4 things: client ID, client secret, tenant ID, and subscription ID. Tenant ID and subscription ID belong to your Azure account. But client ID, client secret are actually the credentials you need for proper access. So via this flow, we use GitHub Actions Store to save these secrets, which means those Azure credentials are saved in GitHub Actions Store, which means, yes, this is a duplication of secrets. And if it's saved as a long-lived secret, I'm sure I'm not the first person to tell you it's not a good habit. There are a lot of security concern. Once it gets leaked out, it can be, leads to some nightmares. And definitely, so cloud secrets are stored as long-lived secrets in the action store, which is not a good thing. Then definitely there's a duplication of Azure resources in GitHub Action Store. Consider the scenario, right? It's not just one workflow in one repository you might want to implement. You might have different repositories of GitHub. What will you do? Will you create different Azure SPNs and keep on saving those secrets in GitHub Action Store? Doesn't sound good to me, or I'm sure doesn't sound good to you as well. And definitely this creates a big problem, and secret management becomes a lot more difficult. The duplication, leakage concerns, and sometimes there might be secrets that might get expired, right? What will you do? Will you keep coming to the action store and keep updating that? Doesn't look good to me, you, and even to Coco. So though Coco was able to access the resources, but Coco isn't really happy and satisfied. But wait a second. We also understood the concept called OIDC here, right? That might have one role to play. And yes, you guessed it right. We have support, OIDC support, which is now provided to us by GitHub, which will make this process more secure. How will this happen? There has to be some trust thing to be developed. If I'm not passing a client secret, which acts as my ID password, there has to be certain other way to establish that trust. And yes, that is done by the GitHub OIDC provider now we have. So with this OIDC support, the new flow looks like this. So we have the GitHub workflow, and there is an OIDC provider. We make a call to the OIDC provider and say that I want a ID token. Okay, OIDC provider will check from where this request is coming. What is the repository? Who is the one making the call? Which branch? Or what are the other details? It can get actually from any client. And on the basis of that, in a well-structured kind of a JSON JWT, it will return an ID token. So that ID token will have details about the client who actually requested for it. And not just that, it will also have an expiry time, so that we discussed secrets are not good if it's long-lived secret. There has to be certain expiry to ensure properly things are being accessed and refreshed. So now this ID token is used instead of the client secret which we were using before without the OIDC support. So as you can see, the other parameters are same: client ID, tenant ID, and subscription ID. But what we changed is the client secret part, which was being saved in GitHub Action Store. I need not do that. I have ID token now. So what happens when I pass this ID token to Azure? Azure will validate it. How will it validate? It will actually check, if I have any pre-established trust with any of the OIDC providers. And as I said, GitHub's OIDC provider has now configured a trust factor with Azure, so that it can check, okay, if you're getting a token issued from me for these many credentials, for these workflows, I request you to give the access. There are a lot more processes, a lot more checks, which Azure does, but in a high level, this is what the validation process looks like. So instead of client secret, I have the ID token, and I pass that. Coco, obviously Coco passes that, and in Azure validates it based on certain criteria, and access is granted. So now, no, Coco is not saving anywhere the secrets in Action Store, not duplicating it. Even if the client secret expires or other credentials expire, Coco can easily go and request another ID token. Because if the GitHub workflow is a valid client as per the pre-established trust between the Azure and OIDC provider, then it means it will get the required access. Need not worry, I will also tell you how the process is to set up this trust factor, so that it becomes easy for you when you are creating your applications. So now, yes, we were able to make Coco happy. This worked for Coco. I'm pretty sure this will work for you as well, securing Azure resources using OIDC support in GitHub Actions. So now I'm thinking you might be wondering, okay, this Coco is happy, but the Coco and me also need some happiness. How to get started? This is all well and good, but there can be certain things which can be done by me, and all things this can be set up. So for this presentation, I have just scoped it down to a bit. Like, I am assuming that you have certain service deployed to Azure. And even if you're not very comfortable now writing a test workflow, GitHub workflow, with the shared resources I will share, then you can actually write those steps and properly invoke all the actions, all the functions, execute all the scripts. But the key thing here is using the OIDC support, for which you actually need to do certain setup part, which will establish that trust factor, and you need not provide the client secret. So it's very simple. I'll just share with you the steps for that. As you can see in the screen, this is a screenshot from Azure portal. You can go, I hope, as I mentioned, using SPN, using apps to access Active Directory resources. This is a build up on that. So you create an application in Azure and you register that application, Active Directory application. So you can see in the menu bar, there's an option called certificates and secrets. So you open that, and here you can actually set certain secrets, certain certificates, client secret, federated credentials. So these will, do the configuration, according to which this application will let you or any client application access the Azure resources. So once you go click on this federated credentials, you will see an option to add a credential. So you can see here from the drop down, there are a couple of items for which you can create the federated credentials. The first one, GitHub Actions deploying Azure resources. This is what the scenario I was talking about. So once you select this is actually a setting up, giving one workflow or maybe one repository or maybe one organization proper right to access the GitHub resources. This is how it looks like. Once you click on that, you will see that this issuer, this is that OIDC provider we talked about. So the trust is established between that OIDC provider and Azure. But now the request comes, right? So now how will Azure check whether it's a valid request or not? Request is coming from the right OIDC provider, but for example, it's coming from another repository for whom I didn't even intend to provide the rightful permissions. So that's why the repository, the organization, entity type is basically, it can be a particular environment, a particular branch I want to restrict my access to. Those things come into picture, and I set the pre-established trust factor here with OIDC and Azure. On the basis of this, whenever I make a call to the OIDC provider and an access token is returned to me, that ID token is passed to Azure. Azure validates it, matches these conditions, whether the person who is, the workflow or the any client app is requesting the access is the right users. Does it have the right permissions? Going back to the story of authentication and authorization. Yes, those things are checked, and yes, definitely, then the access can be granted. So this is pretty much covers about how we access the Azure resources using the GitHub OIDC support via GitHub Actions. I hope it gave you some clarity and certain, pointers how to get started, what's the benefit, and certain terms clarified, certain meanings, and why are we doing so. I hope that part is pretty clear. Being a PM myself, now I'm very much focused on the why part. Why am I even giving credentials? Why am I doing this pre-step again? And for you also, I feel it's really great to know why we are doing things so that we are really inspired to do that. This is from my side. And as I promised you in between the session, I will give you proper resources which you can go through. And, just like the Coco here, your Coco can be happy. The Coco in you keeps smiling and is secured with all the proper secure applications that are there in place. So these are resources you can understand more about Microsoft Identity Platform, OIDC, know more about GitHub Actions. This was the Azure login action, which I talked about today. You can involve a lot of many things. For example, you can directly deploy a web app to Azure using GitHub Action. There are a lot of things in there in the marketplace available for you. Then Azure app registration, for which I showed the trust factor establishment comes from there. And then Azure login action. And there are different security protocols, which you can read more about. I hope you enjoyed it. And you had more fun. The Coco is happy, and you are, I hope, happy as well. Feel free to share your feedback with me, and I'll be happy to connect with you at this URL which I've provided. I hope you had lots of fun, lots of sharing of good information, and all the best. Stay secured, stay safe over the internet. Thank you so much. Bye bye.
That was a great overview of various different concepts that are important in enabling secure access from GitHub to different cloud platforms. Kanika talked about the specific GitHub and Azure scenario and also the new GitHub OIDC provider that makes it possible. This eliminates the need to have long lived secrets and also alleviates the credential lifecycle management and other concerns such as secret leakage and duplication. Secure and easy. Developers, are you listening?
Not sure about others, Richa. Developer in me is definitely listening. That's a good segue for another aspect of SDLC, right? Like, if whenever you're developing any good application or product, how do you ensure the reliability of the product? Of course, the answer is testing, right? But when your product on application matures over time, when it becomes more complex, how do you scale up testing? That's always a challenge, right? And I think that's what Mayank Bole is going to teach us. He's a co-founder of Lambda Test.
Yes.
Hey everyone, it's great to be talking at GitHub Constellation India, and I hope you guys are having a great time. I'm Mayank Bhola. I'm co-founder and head of products at Lambda Test. And today I'm going to talk about a topic which is very close to our hearts. It's about shift left. In this talk, we are going to discuss about the current challenges that organizations face while moving to shift left, some of the solutions that are out in the market, and what are the ingenious ways on which research is currently happening, and finally, what is the Lambda test take on this problem. So let's talk about what shift left testing actually means. So shifting left actually means that we are moving the testing on the earlier stages of the software development lifecycle. Earlier, the testing used to happen only before the product was getting shipped on the production. But now, with the emergence of agile methodologies, organizations want to steer very very fast, and they want to ship out the code on the production as fast as possible, and that requires to test out in very smaller chunks. And if we move the testing to the earlier cycles of the development life cycle, it actually means that the confidence is going to be much greater. But ultimately, when we say that we want to move testing to the earliest stages of the life cycle, it exactly means this. Now, this is underneath of the iceberg. So here we exactly mean that we need to test on almost all the phases of the software development. From the outset, it looks like that we are only going to test out when we are going to code out something or design something. It actually means that the testing should start from the planning phase. And this is where the test-driven development and the Cucumber emergence had all started. So if you look at this diagram, it's very clear that starting from the planning until we deploy our code on the production, we have to test on every single phase. So this is what exactly a shift left testing means. But a very common question, why do we need to do that? And there are lots of research that have happened over the last 2 decades that clearly show that the bug that is caught while in the development phase cost much less than it would have when found in the production. And there are lots of memes out there on the internet, a lot of posters out there that explicitly state the dollar amount that companies had to lose because of the bugs which were found on the production. And one of them said that it cost around $10,000 to fix a bug on the production, and it costs around only $100 if it gets caught while in the development phase. The numbers might not be realistic, but the difference between them is representative of the scale of what companies and organizations can save if they can fix the bugs while right in the development phase. And that all creates a premise of why shift left testing actually matters. And before we move on to the reaction phase, the startup culture, the agile methodologies, the fierce competition in the market, and the urge to push out several times in a day has actually led to this movement and have actually accelerated in the recent times. So now, when there are multiple competitors outside who are pushing code faster than you, then it becomes the responsibility of an organization to keep pace at the competition that they are facing. And it ultimately leads to shipping more frequently. And that ultimately boils down to testing even more frequently. Now, let's talk about the reaction it has. So, on we saw what the good sides it had, but let's also have a look at what bad side this shifting test actually means to the organizations. First of all, we have opened the floodgates. We are saying that we need to write more and more test cases, but ultimately that adds up the pressure on the code repository. Since we have opened the floodgates, the rate at which the test will enter the system will be very, very large. And in no time, there will be so many test cases which will be very difficult to handle. Moving on to the next part, not just that on the number, but also on the quality. Since so many test cases are entering into the system on the name of shifting left, there is no control mechanism on how the quality of these test cases is measured. Currently in the market, test coverage tools and code coverage and some other static analysis are doing the job, but they are not appropriate and are not sufficient. There's a lack of tooling in the market that can actually shed some light on the quality of the test cases which are entering the system. And finally, if there's so many test cases are written, it's not actually possible to run them all. You'll see the reason in the next slide. But what it actually means that the organization are forced to run the test cases on the batch of commits. Now, for larger organizations who is committing 100 times in an hour, it's not possible for them to run all the test case at all the times. So they fall back to running the test case on a batch of commit, let's say 50. And the problem is that after you run a test case on a batch of 50 commits and a test case failed, you do not know which commit broke the build. So you lost the ability to revert that git commit. But then the other option that you left is only to roll forward, which in some cases might not be the answer. So that poses a large problem on the number of test cases that are entering into the system and how to control that. What it actually means, we saw the reactions and the bad sides of shifting left, but in actual day to day, the problem manifests themselves in much more variety. For example, we start seeing high test execution time, which actually leads to the clogged CI pipelines. Now, an organization who used to commit 100 times in an hour, now it's not possible for them to spend multiple minutes on every commit, because now, since more and more test cases are being added, there'll be a time in which it will not be possible to run the CI for every commit. And that can lead to multiple problems. One, velocity leakage. If a single CI is blocking your resources, you will be limited in the number of parallel CI. Plus, there'll be a huge queue of developers who will be waiting on each other just to run their jobs. And that's a huge risk. The organization, if they leak the velocity, the entire momentum is going to get suffered. Secondly, since we do not have control over the flaky test cases, that means that there's a lack of quality control. And ultimately, it leads to the lack of confidence in the testing itself. And what organizations start seeing is that developers try to find some hack ways in which they are able to skip the test cases because they have hard deadlines. They need to push out code very, very frequently. And if CI is not helping them out, they'll try to dive into some other directions in which they are able to maybe skip the test cases, which actually shatters down the whole methodology of testing itself. And then ultimately, when everything of this kind happens, it's very hard to measure the ROI of all the expenditure that is going into the testing, the infra, the resources, the manpower, the strategy. And it poses a question, why are we even testing? So now let's talk about the solutions. The good part is that the big tech organizations like Google and Microsoft started seeing this problem much ahead of the time, and they have been researching over these problems over decades. So now, when the rest of the organization, the rest of the world have started shifting left, they are not without any solutions. There are some small pieces in which they can actually try to solve this problem in some miniature ways. And what currently organizations do is that they try to stitch away these smaller solutions to make them work for them. Essentially, in the nutshell, it actually means that there is no standard solution out there, but there are some bits and pieces which have to be converted into an ad hoc solution for every organization. The bad part about is that there's every time an organization reaches a scale where they have to think about solutions for these problems, they have to reinvent the wheel. So one of the most apparent solution in this case is that why are we running all the test cases? If we have an insurge of large amount of test cases, does it make sense to run all of them on every time? Obviously, the answer is no. But how do we do that? Let's start discussing about what people have been doing since inception. The most earliest example of selective testing was done using tags. And traditionally, the QA teams and the developer teams have started labeling their test cases, and they only used to run a particular tag on a particular stage of the SDLC. For example, they used to run smoke tests on the staging servers. They used to test regression on the pre-prod servers. So it was a very introductory phase of the subset selection of the test cases, but that was definitely not at all effective. Next, the monorepos came into the picture. Although monorepos are not targeted towards solving this problem particularly, but they did provide some of the directives in which we could say that if only one of the sub package is getting impacted, we do not need to run the test cases of all other packages. But then in terms of accuracy, this is totally incorrect because sub packages might have interdependencies in them. So if we just run the test cases of the impacted package, we are at risk of not running the essential test cases. So again, this provided a solution for a little bit time, but then it got apparent that this is not the ultimate solution. So how did we actually solve this problem? Facebook, now called Meta, is using an AI to train every single line of commit that is going to their system. And that system is able to pinpoint the exact subset of the test cases that need to run. Now, obviously, this is working at scale for them. But if you think about a solution, this is not well fit for a small startup or an organization which doesn't have that many resources in terms of the machine learning and the AI. And secondly, since the code of every organization is very typical to them, there's no possibility of a generic AI solution that can fit over every code base. So if an organization goes this way, they have to actually work harder. Now, on the other side, there has been interesting research that is going on, which got started decades ago, and this is called test impact analysis. And it actually means that if a system can take an input of a Git commit and actually figure out which all paths got impacted, and if we can attach them to a single test case, we can actually map out on every single commit which all test cases got impacted. Now, the precursor to this kind of solution was Blaze, which was a build tool, and this article published by the Google specified that it can actually build dependency graphs, and which can actually tell that on every commit which all code paths got impacted and essentially which all test cases needs to run. This can also be done manually at a very lower scale. And that would mean that if we can create a simple manifest file, and for every single test case, if we can write down the modules and the file it's dependent on, and if we can feed this manifest file to a system, so that system can dynamically tell which all test case needs to run depending on the Git diff. But then this was just for the lower scale. The best part now is that test impact analysis have actually got quite mature now, and Microsoft is leading the effort all along. But we'll try to see in a little bit detail like how test impact analysis can actually work for you. So if you can actually parse the source code and actually see that which all test cases are dependent on which all modules. Now this is very easy from doing static point of view. If we input, for example, a Python file or a JavaScript file, it's actually possible to trace down all the dependencies. And this is how the actual package managers and the module resolvers work. And these module resolvers already know the dependency graph of every single file and every single module. So if we can somehow take away this graph from these module resolvers and attach it to the test running system, we can get a way in which we can decide which test case to run. And this is exactly how the Jest is doing. Jest is a very famous open source testing tool for JavaScript. And it exactly uses this kind of dependency mapping, and it can decide which test got impacted. But unfortunately, it doesn't work on the CI systems. But yeah, it's a good step in this direction. So currently, if you see what the status quo of TIA, it started with the Google Testa. It's a very old tool that Google itself released over JUnit, and it used to selectively test only those test cases which got impacted and which were failing previously. The second attempt was made by ThoughtWorks. It was called ProTest, and it actually used to orchestrate the test cases in the load balanced manner, and also used to run only those test cases which got failed last time. It was followed by JTestMe. It again is released by ThoughtWorks, and it was piggybacking over the Java testing tooling. And it provided up to a certain extent a way to run only those test cases which got impacted by the previous commit. And if you talk about the latest tools, Azure Pipeline TIA is already available in the market, although it's a commercial tool, but it does provide these advanced functionalities where the end developers do not even have to do anything extra in order to enable it. The platform itself is able to decide the dependency graphs. It's able to selectively test the impacted test case in real time, which is a very great improvement over it. And then followed by the Jest. Now let's talk about the second concerning topic about flakiness. Flakiness is everywhere. It's not about just shift left, but it becomes even more important because now even more and more test cases are entering into the system. Now let's see like how people have been combating the flakiness. So the most trivial and the most archaic form of flaky test detection management was that whenever any test case got failed, team used to manually rerun only those test cases. So earlier there was no such concept of platform itself giving you this result. So that is why users had to do it by themselves. This got better when the testing framework started providing the native support, and the testing framework would automatically rerun only the failed scenarios. And if this test case could pass in the second or third run, it would mean that the test case is flaky and it would just report it back to you. Then it became a little bit more evolved, and the platform and the frameworks were able to correlate the test logic changes to the test results. And if there was no change in the test logic or result, and still the test case was giving different outcomes, the platform or the framework would mark it as flaky. And that was just the beginning of this empowerment to the end user. And end user was now is now more aware that yes, some test cases are flaky without this happening in the production earlier, because before these tools, it was very difficult for somebody to figure out that it was a flaky or not. But with these technologies, it's actually possible for them to get visibility that yes, certain test cases are flaky. And finally, the most matured evolution in this stage is that if we can proactively test our test cases, so that takes us to the term, do you actually test your tests? The answer is yes. And this is what some mature organizations are doing. For example, Netflix, Spotify, and various other organizations which have open sourced their literature. And this is a very interesting thing, because if our system can detect which new test cases have been added into the system, or which test cases have been modified in the previous Git commit, we can actually run these test cases through a pipeline and test them using various different strategies. So one of the most common strategies is running a single test case X number of times. So if that test case is not following a single pattern, or it's changing its behavior, the platform would immediately block that test case from entering inside the system. The little bit advanced approach over this is jumbling the order of the test cases, because multiple times developers only assume that the tests are going to run in order. And when they don't, the test starts showing some flakiness. So if we can somehow jumble the order of the test cases, that would again provide us a way in order to block those test cases without even entering the system. Next is, some of the test cases show flakiness because they are dependent on the network, the timing, as well as some resources. So if we can exponentially degrade the resources, For example, if our test case is running fine over 1 gig of memory, we could again try it at 750 MB, 500 MB, and then go it down till we find that at which stage the test starts immediately failing or becoming flaky. And the most state of the art ways to test out flaky tests is the mutation testing. Mutation testing takes an interesting turn in which it dynamically changes the underlying code under test to figure out if the test case is using some hard-coded logic or it's actually using the correct logic. So the mutation testing is going to change the underlying source code and then run the test again. So if the expected outcome is different, we can exactly tell that this particular test case is flaky. And finally, with all these test cases coming into the system and having the flakiness, it becomes imperative that we have a huge amount of visibility and observability, because there are so many test cases, it's not possible to view them under a single report or just once. And this gives rise to the new section called observability. And multiple tools out there in the market have started having this kind of plugins and features where you can actually see the entire history of the test cases over entire runs, and they can surface some important patterns which are not possible without them. Datadog is just one of the examples. This is an example of how SoundCloud is doing the analytics, and they have been using Grafana backed by some data sources. And we can see that the amount of effort it takes, but it's actually worth it, because now it's very, very easily visible which test cases are becoming flaky, which are having the most bottlenecks, and how many times a particular test case is run. So any organization which is running testing at scale and it's aggressively adding test cases, it's very important for them to store the every execution of a test case over entire history. And that is where the pattern starts to spruce up. So either manually or by some third party, it's actually recommended for them to try out these tools and maybe store the results to see these important patterns. And finally, this is an example of how Spotify is storing the test results and creating their ad hoc visualizations so that it's very, very easy for them to figure out which test case is flaky. And this is, in my opinion, a very interesting view to actually have a bird's eye view across your testing. And we have been closely following this research for quite some time now, and we started feeling this pain at LambdaTest itself. And that is what gave birth to LambdaTest Test at Scale. It's our take on this problem, and we have open sourced the solution over GitHub. Currently, this platform supports all the major JavaScript frameworks like Jest, Mocha, and and Jasmine. And we are going to release integrations for the other languages like Java, Python, Golang very, very soon. So essentially, Test at Scale is solving all the three previously mentioned problems of selectively running some test cases. Second is combating the flaky test using all the strategies, as well as providing an open framework in which an organization can construct their own kind of testing policy for their flakiness combat. And finally, the observability, which actually provides you the needle in the haystack problems, and obviously tells you which test cases is going to become flaky by using some trend analysis and by using some anomaly detections. I'll try to show some example of what Test at Scale is providing in terms of the analytics. So first of all, this view, and this is definitely inspired by what Spotify is doing. And you feel that this kind of interface will be helpful to multiple organizations out there. It's very, very easy to figure out any platform level issues or some degradations and some anomalies, and to actually get the ROI. How many times did we actually run the test case, and what has been the result? If you can notice the above gray line, it actually means that a developer has explicitly skipped a test case, which is a very concerning point. Secondly, we also provide frequencies and the trends over every single execution by every single commit. So Test at Scale is going to provide this intelligence over every single commit that we are having. And finally, we also provide analytics over the system consumption. For example, the memory and the CPU. This, in our opinion, is a very important metric, because if there is some anomaly detection in these values, we can actually detect a test case can become flaky later on. This is very, very helpful and time saving. This is another interesting view which actually shows the ratio of the impacted test case. So we can see that the impacted test case constitutes a very smaller percentage of the entire testing suite. And when this happens, it's actually quite apparent the value of running only subset of the test cases. This you can actually tell the ROI of running using test at scale, or maybe some other strategies in which you're only running a smaller set of test cases out there. And that was it. I hope I tried to bring back the point of why shift left testing is important, what are the current problems that the industry is facing, some of the common solutions, and our take on the test at scale problem. And we definitely hope that test at scale GitHub repository is going to help us and other organizations is much more variety of ways and help us embrace testing even more fiercely. Thank you so much.
Wow, that was an insightful session. Like, I never thought testing can become this very complex, right? The amount of strategies that one can induct into the testing. Wow, that's amazing, right? Like, you can bring in AI and you can think about how testing the test cases, and you can also think about choosing the right set of test cases, all for one thing, right? The need for speed. There's increased need for velocity, right? So we need to adopt the strategies. Thank you, Mayank, for educating us. Richa, what do you think?
Totally agree. I totally agree. Being an engineer, I can relate to this. Testing is such a critical part of the journey, and often something that we should be more intentional about. Whether it's about smarter testing or more reliable testing. The testing the tests was a good one to take away. And yeah, so like I said, very, very important part of the DevOps journey. And we're going to hear a little bit more about, things that developers care about in that journey. But before that, how about Divakar, we look at a few tweets that have been coming our way.
I'll be always game.
All right, we have Firdos, and I'll take a few seconds to just parse that. Yeah, looks like we have someone who's been looking at some of our other tracks. We have a lot of stuff going on the security side, and really one of the pillars at GitHub is about trust by design. And I hope you all have been looking at some of the sessions on the security front that will tell you more about how GitHub is empowering developers to write secure code.
Nice. Do we have more tweets? Shamod, Woot. DevOps track just started. Nice. Thanks for showing that energy.
Yes, absolutely.
What's up next, Risha?
All right, let's see what's up next. So, people are always curious about how GitHub does its own DevOps, right? Developers are always looking for ways to make their pipelines more efficient and more reliable. So in the next session, we are going to have Trilok, who's the Director of Engineering at GitHub, and who's going to tell us more about the mechanisms that GitHub uses to increase deployment frequency or to reduce lead times for pushing changes to production. You'll hear about approaches for feature rollout, improved CI/CD, and also faster development using code spaces. So over to Trilok.
Hi, welcome to GitHub Constellation India Day 2. I'm super excited to present this session on how GitHub does DevOps. Let's get into the session. Hi everyone, welcome to this session. DevOps is the union of people, process, and technology to continuously provide values to customers. DevOps enabled roles like development, IT operations, quality to coordinate and collaborate to produce better, more reliable products. This is the agenda that we'll cover today. We will start with the common metrics typically tracked to achieve good DevOps. We will then understand how these metrics are met by discussing the mechanisms of feature rollout, continuous integration and deployments, and finally faster development using code spaces. Let me introduce myself. My name is Trilok and I am a Director of Engineering, leading teams in GitHub Actions across APAC region. I love developing applications to help make our lives and society a better place. I seek new problems and challenges to solve on a regular basis. I work in GitHub Actions and helping customers realize our vision of GitHub Actions is used by every developer to automate their entire software delivery workflow. I love adventures and venture into nature more often than with hiking and trekking activities. I love animals and I have several pets at home. I constantly keep checking on my fitness goals and trying to get back to my healthy lifestyle. So let's look at our key metrics that we will discuss today. These are the key metrics. These are also called DORA metrics in DevOps world, and that are used to measure software delivery performance. The first one is how frequently is the team deploying? Some of the questions that we can ask is, are there any hindrances or blockers? Do we have to do too many manual processes before the team deploys to production? And the lead time is measured in getting a code to successfully run in production. This touches upon some best CI/CD practices and automations. The last two metrics are focused on achieving a healthy and available system to gain customer trust. Incidents do happen, but the important thing is how fast we can close on the time to detect and time to mitigate in order to recover from these incidents and get the system back to a good state. As we deploy frequently, DevOps practices make sure we have the right mechanisms to roll back and proactively reduce the blast radius of the changes being pushed. We will discuss several mechanisms to where GitHub uses several mechanisms to achieve these metrics and also exceeds them in certain cases. We will understand some of the good practices, what we follow to roll out a feature or a customer value. Feature flags are part of safe deployment practices. We use feature flags a lot, and we use feature flags to reduce the risk of deploying to production. Any potentially risky change is put behind a feature flag in the code, and when the deployment is done, we enable the feature flag to everyone or to a percentage of actors to minimize the impact of changes. If something goes wrong, we can always disable the feature flag completely within a matter of seconds without interrupting other deployments. If there were no feature flags, you probably would have to revert the PR or rollback deployment. We, of course, do these mechanisms as well, but feature flags are something that is used across many teams in GitHub. We don't use long-lived feature branch. That is also one of the fundamental principles that we do to achieve good DevOps practices. Instead, we use short-lived feature branches with feature flags as a blast control mechanisms. Why don't we use long-lived feature branches? Because small batches are easier to review, and engineers can do small pull requests. And generally, the smaller the change, the lesser the chance to get something really wrong in production deployment. And finally, not using these long-lived feature branches avoid a lot of potential merge conflicts and clashes that can happen with other features that are currently under development. Feature flags also helps us to test and have more control on the testing feature. In our development environments, we can toggle feature flags from the command line. We can disable and enable as the application is running. We do the same thing in automated tests as well, in our long-running tests and a short-running required test. In our CA also, we have two different builds, one that runs with the feature flags disabled by default, and another one that runs with all the feature flags enabled by default. This drastically reduces the chances of not covering the code paths, and it also increases the confidence on code coverage. In production, we can enable or disable feature flags in a query string of a request. Once we have understood feature flags, we can now understand how it benefits in defining the shipping strategy. Features developed in GitHub typically go through different phases. Initially, we enable it for individual actors, where we flag employees working on a feature to enable the flag to customers that are experimenting the feature. And if they are trying to have a problem, we are trying to fix. After that, the feature flag is enabled at a staff level. And by staff level, when I say that when a feature is almost ready to be released, we enable it for all GitHub staff, all the GitHub employees, and publish an internal post for awareness, and then create an internal issue to gather feedback. The third stage is the beta stage, where when you are about to release an important feature that will impact, let's say, open source maintainers or other type of users, we want to test this feature with a small group first. After some time, we may interview them, gather feedback, validate the implementation. And the fourth stage is we enable for a percentage of actors, which is a group, and we enable this in order to get more data and more testing done. And when the percentage of actors is changed, a message is sent to our deployment channel. So engineers are aware of this change. So we know that we have increased the scope of this feature. And the last stage of deployment is Dart shipping, which allows us to enable the feature flag to a percentage of calls. This is different from previous mechanisms because the actor or the user can get the feature enabled in one call. It's not sticky. And in another call, the feature might not be enabled. This mechanism is not meant for features that are visible for all users, but for changes like performance improvement in a query and whatnot. And once the feature goes through all these stages, some stages are optional, of course, like dark shipping, and features are made generally available. And once the features are generally available, a blog post is typically published, and feature flag is kept for some time for easy rollback. And don't worry, we have some mechanisms like linting, and tooling around GitHub Actions to pay the tech debt that is incurred due to creation of the feature flags. We use chatops primarily to interface and execute DevOps command. This can be integrated in Slack and other channels. And the developers can use Slack commands to run CI builds, queue builds in trains, and deploy and monitor code in production. Hubot is what powers this chatops command. Feel free to check out what Hubot does in hubot.github.com. We'll see examples of Hubot commands in the next slides. This is a chatbot that was built by GitHub and it's open source. It's called Hubot because it has a human-like personality where it is fun and it can remember the older commands, and it makes really engaging. Let's go to the next section. After we discuss the feature rollouts, it's important to understand how we are improving our continuous integration. We identified that developers typically waited for 45 minutes for a successful run of our continuous integration suite to complete before merging any change. This 45-minute lead time was repeated once again before deploying a merge branch. So in a typical scenario, developers would have to wait for 2 hours, which is really insane. And deployment frequency is really high in GitHub, and 2 hours is really painful for a developer to wait before pushing their changes. So this is what we have done. We brought down the 45-minute CI to 15 minutes, and I will go through the one key thing that we achieved to do this in the next slide. But before we go into what we did, let's understand why we did it. So I'll give you some stats about GitHub.com. GitHub.com is a Ruby monolith, and every commit to a pull request triggers 25 CI jobs and requires 15 of those CI jobs to complete before merging a pull request. This meant that a developer at GitHub spent approximately 45 minutes and 600 cores of computing resources for every commit. That's a lot of developer hours and machine hours that could be spent creating value for our customers. And also to understand the optimization, I need to introduce you to something called GitHub Enterprise Server. GitHub Enterprise Server is our on-premise offering of GitHub. GitHub.com is our online, and we have GitHub Enterprise Server, which is our on-premise. We ship a new patch release every 2 weeks and a major release every quarter to GitHub Enterprise Servers. We had 2 long-running test suite added to the CI workflow to ensure the pull request did not break the GitHub Enterprise experience for our GitHub Enterprise customers. It was also clear that these 45-minute test suite that we added for Enterprise did not really provide value for GitHub.com deployments. And GitHub.com deployments happen several times throughout the day. And again, driven by customer obsession and developer satisfaction, we have developed something called Deferred Compliance Tool to save time with CI. And I'll explain the Deferred Compliance Tool in the next slide. So Deferred Compliance Tool is what we did to reduce the CI time. Deferred Compliance Tool is integrated with our CI workflow systems, and it strikes a balance between improving the lead time for a change in deploying GitHub.com, at the same time creating accountability for the quality of Enterprise Server. We don't want to bring the bar down for Enterprise Server as well. So the long-running CI jobs are no longer required to pass before a pull request is merged. But the Deferred Compliance Tool can monitor for any test failures. So deferred means that we don't require the builds to pass in order to merge or deploy until they have been failing for a certain period of time in the default branch. And compliance means that, hey, we still have eventually this builds will succeed, and we want it to be green in order to continue deploying and merging the next set of changes. We'll try to understand it by a diagram. As you can see, the developer creates a PR to merge the change, and required CI jobs and non-required CI jobs are started in parallel. If required jobs are completed, the well and good, the pull request is merged and deployed. But say if a long-running CI job fails, a GitHub issue with a deferred compliance label is created, and the pull request author and code segment code owners are tagged so that they can take an action. We have a warning message also sent to the Slack to the developer, and the 72-hour timer is kicked off. The developer now has 72 hours to fix the build and push a change or revert the pull request, either three of them. A successful run of the CA job automatically closes the compliance issue, and the 72-hour timer is turned off. But if the CA job remains broken, say more than 72 hours, all deployments to github.com are halted, barring any exceptional situations, right? So until the integration tests are fixed on the enterprise server. So this ensures that we create accountability and ownership for all developers, and enterprise server sanity as well as github.com sanity is also maintained. This 72-hour timer is customizable, but our analysis showed that 72 hours is good enough because we have developers ranging across time zones, starting from developer checking in something on San Francisco on a Friday and Friday afternoon, and they don't unintentionally block a developer who is going to start their day on Sydney on a Monday morning. So that is something that 72 hours really keeps track well. Now let's look at deployments and how GitHub does deployments. There are some really good concepts like GitHub deploy trains and merge queues that I'll touch upon. The first and foremost is to understand what's a deploy model. Branches are deployed before merging them to main. So we don't merge and then deploy. Instead, we first deploy and then merge to main. This meant that the developers can add changes to a queue, change the status of a queue, and organize groups of pull requests to be deployed and merged. So that gives more flexibility, and that's the reason we choose this model. For deployments, we use trains to conduct build deployments. Before deploying a build, there is a checklist that the developers have to go through that includes write code reviews, lintings, unit tests, and whatnot. But once they are ready to start the deploy, they join the deploy queue via chatops command. Qbot again comes into picture and notifies when it's your turn to deploy. To save time, you don't have to keep looking at your Slack channel. Approval checks from the reviewer group are needed, and the developers are also recommended to test their changes in labs environment. And they do one last check by verifying the feature flags. And once the check is done, the rollout happens. And we use canary and auto deploy to progressively roll out the traffic. I will explain that in the next slide as well. But we start with 2% canary, 20% canary, and then followed by 100% production deploy. So that is to make sure that the impact is not huge on customers. So this all functioned using chatops in a Slack in a room called .com ops, which is an internal Slack channel. While this is a very simple system, it really is confusing because there are hundreds and thousands of messages in a single chat room to manage the queue, to deploy, and to monitor what's happening. And all of a sudden, this channel, which was a crucial information system, is just being overwhelmed, and developers could no longer track their change through the system, which resulted in reduced capacity for the developer and an increased risk profile for GitHub. So we have to do something about it, and we were able to create some mechanisms around it, which I'll explain in the next slide. So you can see the pain that developers would have to go through. This is just one small snippet where chatops display the statuses of your train. And this is one step of about a dozen messages spread across hundreds of messages and hundreds of threads. So it's really hard to keep track and validate the state of the deploy. So this is a good justification for us to do some improvements in this area. The entire system, for production deployment, works like a state machine. This diagram shows an automatic progression between, let's say, 2% canary, 20% canary, production deploy, and a ready to merge stage. There is a 5-minute timer that separates each of these deployments. And finally, a pointer is automated to progress across the data model after the timer gets completed and stages were deployed. So this is our stage-by-stage canary-based deployment pipeline. So what resulted was a state machine back deploy system. So we know that it's a state machine, and what we did is we converted that to a UI component. This was combined with the traditional setup. So we have the goodnesses of both. And you can see that overview of deploys which have recently been deployed to github.com. And rather than tracking down various messages in a noisy Slack channel, you can go to a consolidated UI. You can see the state machine progression mentioned above in the right. On the right, the state machine transition is pointed out so that you have a mental model of that, and the user can see the deploys progressing here in this UI. Drilling down into specific deployment. So the previous slide was the list of all deployments, but now when we drill down into each deployment, you can see everything has happened during the specific deployment. You can see that each stage of deployment has a 5-minute timer between them. You can pause the deployment to give a developer more time to test. In case something goes wrong, we have a quick way to roll back in this UI as well with the drop down in the right top corner. So that's another good thing that this UI provides. Finally, the entire system could be monitored and started from Slack. Just like before, we found that this is how developers typically want to start their deploys. And they would go to the UI to monitor in the UI component, but then they would come back to the Slack channel to understand the collaboration and to see the conversations that are happening for every deployment. So it's a combination of Slack channel and the UI that we use to do the deployments. Of course, we also look at deployment dashboards to gain confidence, which includes looking at canary progress, response times and statuses, SLOs, application health, database health. And we're also constantly surfacing alerts during and after the deployment in the .com ops channel. And finally, we use Datadog and Sentry for monitoring alerts and issues. So now that we have understood the deployment practices, let's go into the local development and how do we make sure that the lead time is increased via code spaces. So we use code spaces, which is one of the GitHub product. Do check out code spaces if you have not already checked it out. GitHub is being built using code spaces. So GitHub developers typically do the local code setup using GitHub code spaces. Some interesting fact about GitHub codebase is around 14 years old. The first commit was pushed when just Rails was 2 years old. So it means that we predate Rails to a certain extent as well. And most of the commits are coming from macOS. So till date, we have millions of commits, and that means that the scale is pretty high even for local development. We have a paradigm in GitHub called scripts to rule them all. Once Git clone is done, there are certain bootstrap scripts that are run to set up and start the server. And this is common across several tools and microservices across GitHub, not just github.com. Typically, it used to take like a half a day's time to run the scripts, and sometimes things go wrong, and people had to open a new issue, and then internal support had to pitch in. It used to be a very manual process when you followed this kind of scripts manually. And we also had this nuke from orbit, which is a command when we use with the script to bring back the local development to a clean state. Let's say if something really went wrong with your deployment or with your local setup, you can run this to remove the installed gems, Git, subprojects, and everything, and bring back the system to a fresh state. So some more stats about GitHub.com. So we have 13 GB. That is the source code size on disk. GitHub.com takes 13 GB, and it takes 20 minutes for cloning. So this is a lot, and that means that GitHub.com typically meant 45 minutes for bootstrapping. So it takes 45 minutes for the entire GitHub code base to bootstrap. So there's a lot of time. And what was our goal? We had to bring it down. So we did certain things behind the scenes. Of course, we used code spaces, and we wanted to bring down the time taken from 45 minutes. One optimization we did was use shallow clone. Many times, a developer working on GitHub code doesn't need the full Git history, right? So they just need the initial few parts of the head. So that's the reason we did a shallow clone, which brought the overall time to 20 minutes. The bootstrapping time from 20 minutes to 90 seconds. So that's a huge improvement that was achieved. And we also improved the bootstrapping further by doing something called GitHub Actions, and we run a nightly build and push Docker images and dependencies. So this is like pre-building, and this saves time for bootstrapping as the Docker images are available already. So with the combination of shallow clone and GitHub Actions, we were able to reduce the 45 minutes time to 5 minutes. So that's like very tremendous improvement in the speed at which the local development can be set up. But are we satisfied with 5 minutes? No, we wanted to raise the bar even high. So this is what we do. We up the ante, and we took an ambitious goal of bootstrapping the entire local development of GitHub code base to 10 seconds. Was it possible? Yes, anything is possible. So this is something that I'll go in the next slide on how we did it. So we achieved the 10 seconds by using something called pre-builds. So pre-builds are nothing but pools of code spaces that are created and are fully cloned and bootstrapped already and ready to go. So whenever a new code space is created and the user wants to do a local setup, one code space out of this pool is used, which saves time for bootstrapping, and we were able to achieve the goal of 10 seconds. And now, since the code base is large, the code spaces also provides a mechanism to control the amount of memory that is used by code spaces. So we recommend changing from 16 GB to 64 GB because the size of the code base, which GitHub.com has, is pretty large, and 64 GB is what we felt is very apt for our use cases. Yeah, by implementing all the above optimizations that were described above, that means by using shallow clone, by using GitHub Actions, by using pre-builds, we were able to achieve a goal of 10 seconds for local development setup. And that also meant that the user doesn't have to go through the script hell and make sure that if something goes wrong while they run the bootstrap script or the start server script, they don't have to debug, because all those things are tested already. And because with pre-builds, they are guaranteed that it will work, and all the user has to do is fix a bug or develop a feature and get started on it right away, and then use the deployment queues to deploy it to production. So the whole lead time that it takes to push a code change to production is extremely small. Yes, with this, we come to the end of this session. I hope you were able to learn a few things about how GitHub does DevOps, and how we were able to achieve the lead time, and how we were able to get faster DevOps CI/CDs done, and deployments streamlined, and certain optimizations, as well as making sure that the developer has a cleaner visibility to how DevOps is, how deployments are happening, and would democratize the DevOps by using deploy trains and merge queues. So, and we continue to raise the bar in this area. And thank you everyone for watching this session. I hope it was useful. Thank you.
Wow, that was amazing. Richa, I'm not sure about you. When I joined GitHub, the first question that everyone asked across is, does GitHub use GitHub? How does GitHub use DevOps? Finally, I have a link to share them, right? I'm tired of explaining them all over. I'm glad that there is a video there, right? Bootstrapping a fresh environment, that too in 10 seconds.
Yeah.
Sorry?
I was saying, talk about raising the bar, right? What you mentioned.
Yeah,
dev environment in it's amazing.
Right. That I think this concludes the DevOps track for day 2. Hope you all enjoy. There are a couple of live workshops that are lined up. It's all listed in GitHubConstellation.com. Please do have a look and have fun. Richard, do you want to remind them of what's happening in day 3?
Absolutely. So tomorrow is one of my favorite tracks, and if you haven't guessed it already, it's education. We have a great lineup of speakers who will tell you more about GitHub's vision of being the home for all student developers. There are panelists who will be discussing the future of hiring and digital skilling, and we will have a few workshops on how students and teachers are using GitHub. Enjoy day 3. Before we sign off, a quick reminder to all of those whose tweets were featured today: do DM the GitHub India Twitter channel with your details so that we can ship you some cool swag. Hope you all had a great day 2. We surely did. And thank you all for joining us today, and see you all tomorrow. Bye.
Thank you all. Have fun. Bye.